You start typing on your phone, see, and instantly it suggests cat, card, camera. It's searching a dictionary of hundreds of thousands of words and finding every match for your prefix between keystrokes without a flicker of lag. A hash table can tell you if a word exists, but it's useless for this. So how does autocomplete actually work? The answer is a wonderfully visual data structure called a tree built out of letters. Once you see it, autocomplete stops being magic and becomes obvious. Let's build one. This is Logic Lab, where computer science becomes something you can see. Today, the prefix tree behind every autocomplete you've ever used. A trie stores words by their letters along a path. Start at an empty root. To add the word cat, we make a branch for C, then under that T the word isn't in any single node, it's spelled out by the path you walk from the root. Now the magic ingredient. Shared prefixes share the same path. Add car and it reuses the exact same C and a we already have, only the final R is new. Add card and it extends car with a D words that start the same way physically overlap in the tree. That sharing is the whole idea. But there's a subtlety. If car and card share a path, how do we know car is a real word and not just a prefix of card? We mark it. Each node carries a little flag, is end of word. The node at the R of car is flagged, so is the D of card. The flag is what says a complete word ends here. Looking up a word is then dead simple. Start at the root and walk one letter at a time. C, a T, each step follow that child. If you ever can't, the word isn't there. If you arrive and the end of word flag is set, it's a match. The cost depends only on the word's length, not on how many words the trie holds. A 1,000,000-word dictionary is no slower than a 10-word one. Now the payoff, autocomplete. You've typed a prefix, say CA step 1. Walk that prefix down the trie exactly like a lookup. C, then A you land on a single node, the node that represents everything beginning with ka. Step 2, every word starting with your prefix is now sitting in the subtree hanging below that node. So you just explore everything beneath it, collecting each path that ends on a word flag. Below ka, we find cat, car, and card. And that's autocomplete. Walk to the prefix node, then gather the words in its subtree. The trie turned prefix into position. Your suggestions are literally just the branch under your fingertips. That's why it feels instant. The structure did the hard part the moment you stored the words. Let's be honest about the trade-off. A trie is fast. Lookups, inserts, and prefix queries all take time proportional to the word length, period. Prefix search, the thing hash tables choke on, is completely natural here. The price is memory. Every node needs room for many possible child letters, so a trie can eat far more space than just storing the words in a list. There are clever compressed variants, like radix trees, that squeeze long, non-branching chains into single edges to win much of that memory back. Tries are everywhere words and prefixes matter. The keyboard, autocomplete, and spell checker on your phone. The search suggestions that drop down the instant you start typing a query. The old T9 predictive text on number pads. And one you'd never guess, the internet itself. Routers store their forwarding tables as tries and use longest prefix matching to decide where each packet goes, a trie lookup happening billions of times a second across the globe. Letters into a tree, prefixes into instant answers. Recap. A trie spells words along paths from a root, and words sharing a prefix share that path. An end-of-word flag marks complete words. Lookups cost only the word's length, no matter how big the dictionary. And autocomplete is just walk to the prefix node, then collect the subtree beneath it. That wraps our tour of data structures, the clever ways we arrange information so computers can use it fast. Next, we go a level deeper. What actually happens, step by step, when your code runs? What really happens when code runs next on Logic Lab? See you there.